There are 11 participants.
Am I unmuted?
Yes, you're unmuted. All right. Well, good afternoon, everyone. Thank you for attending today's webinar with the City and County of Denver. This webinar will be recorded, and the recording will be sent out to all attendees. I have everyone's lines muted to reduce background noise. And my name is Erica Zell, and I'm a project manager for NORESCO. The Colorado Energy Office is sponsoring these City and County of Denver trainings. And to enable us to keep providing these trainings, I will be sending out a short survey at the end of the presentation. Through the survey, you'll also be able to sign up for AIA or IECC continuing education credits. We do want to encourage questions, so please use the chat function throughout, and I'll let our presenter know at the end of the presentation. To start us off, we have Christy Collins here to provide an overview of Denver's community goals and ongoing collaboration between the Offices of Climate Action, Sustainability, and Resiliency, and Community Planning and Development. So go ahead, Christy.
Yeah, thanks. Hi, everybody, and thank you for making time for this. I am going to speed through some information, so I'm going to do the sort of super short version just to lay a foundation for why we're doing so much IECC conversation and training. First, I think it's just important to mention that we are very much aware of and figuring out how to navigate the uncertainty in Denver. We know that there's financial uncertainty. We know that there are big conversations happening related to equity. We're very much part of these things. And the energy piece is a big piece in it. And so we are continuing to push forward with our work on energy because we're continuing to push forward on figuring out how to keep Denver viable for the long term. And as we look at the different goals that have been brought to us by the community in recent years, equity, response to climate change, and affordability kind of top the list with a bunch of other things that go into all three of those. But those three are interconnected, and we really can't achieve any of those singularly. So we really can't address considerations related to finances or related to equity without addressing considerations related to the environment. The people most impacted by a damaged environment are the people with the least means to get away from it. So we have asked ourselves, what is the question? What does resiliency mean for Denver? And there's a list of different things, but at the end of the day, all of them can be connected back to energy in some way. So we are looking through our work related to energy at how we can make each project a positive contributor towards Denver's long-term stability and the health of our residents and our viability as a community. One of those pieces is addressing greenhouse gas emissions. We know that homes and buildings account for 63% of Denver's greenhouse gas emissions. And we know that in 2050, 40% of the buildings that are standing at that time will have been built between now and then. So new buildings matter a lot, and so our codes matter a lot. That's not to say that existing buildings don't matter or that cleaning up the grid doesn't matter. Those are also integral to addressing the greenhouse gas problem. Simply, the Office of Climate Action, Sustainability, and Resiliency, or CASR, that I like to call them, is addressing those through separate efforts. And our work on codes doesn't really reach the existing buildings and the grid, so I won't really talk about that today, but those are being addressed as well. Our work focuses on trying to get to final build outcomes that perform in a really great way. And in order to do that, we have to start thinking about performance from the outset on projects, at the same time that we think about aesthetics, from the very beginning of concept, from the time that we're selecting a site. And that is a conversation that we would really love to help to drive within the community through our work on codes and the rest of the work that we're doing. We know that we can't just pass a bunch of regulations and tell everybody to just go and comply. The market has to move along with the regulations. It's a partnership. And I'll say that a million times if you hear me give the long version of this presentation. We collaborate with the community, and everything that we do is in tandem with the community. It's important to acknowledge the Office of Climate Action, Sustainability, and Resiliency's role in all of this. They are an office that existed prior to now as the Climate Action team, under the Denver Department of Health and Environment, Public Health and Environment. They are now an independent office that reports directly to the mayor. That happened because the community came forward and talked with the mayor, and there was a collaboration to give this office a bigger voice. And the office is growing, and their work is growing. They set a lot of the plans and trajectories for the work that we are carrying out. The first one being the Denver 80 by 50 plan that was rolled out 2 years ago now, that committed Denver to lowering our greenhouse gas emissions 80% below 2005 levels by 2050, which is a pretty ambitious goal and requires a bunch of milestones to be met, including a milestone for all new buildings to be zero net energy by 2035. That is a big aspiration, and it's nice to have lots of goals. We are also in the process of writing an implementation plan this year to get us to those goals. Our major tools for new buildings are going to be the IECC amendments, the voluntary Denver Green Code, which gives us a preview for what's coming up in upcoming IECC amendments, and the Green Buildings Ordinance. We are working in conjunction with community stakeholders every step of the way, talking about what we get into these codes and how we pursue the goals. That zero net energy new buildings goal is kind of a four-pronged goal. Energy efficiency is obviously a really key piece, but so is provision of renewable energy, electrification, getting off of natural gas. And that's a topic that if anybody wants to hear about, I would love to have the conversation. Not everybody understands why natural gas is problematic. And grid stability, because Excel can't get to their goals without our help. So our big tools are the Energy Conservation Code, the Denver amendments to that code, the Denver Green Code, and the Green Buildings Ordinance. Codes are super important, and those mandatory base codes are super important because, as you can see from this little graph, the mainstream buildings that make up the bulk of our development also account for the bulk of our building performance. And so getting those mandatory codes on track gets all of those mainstream buildings on track, and that's where we get our biggest impact from. It's good to note that the CASR team a couple of years ago was able to get Denver accepted into a program, the American Cities Climate Challenge program, where funding is available from Bloomberg Philanthropy to 25 U.S. cities that are pursuing energy efficiencies and greenhouse gas emission reductions at a much more aggressive rate than many of the others. So it's a shared $70 million. As part of that program, the Institute for Market Transformation came out last October and helped us to examine how well we're doing relative to IECC compliance, looking at our plan reviews and our inspections, as well as our built outcomes and how our project teams are doing. I can't stress enough how much we are trying to shift the view to those final built outcomes and not each component piece and part looked at in isolation, but all of those parts and pieces looked at together so that we get to an outcome that performs. We're also looking at Denver amendments. We have 5 code cycles to get to our goal of zero net energy performance for all of our new buildings together collectively. And this graph shows that the national codes are not on track with that goal for us. They aren't for the residential buildings or for the commercial buildings. So we need to use the Denver amendments to pull our codes into alignment with Denver's goals. We used the 2019 amendments as a learning experience, and we went through that process. We got to about 15% better than the base code, and that's pretty good, but that still didn't get us on track with Denver's goals. So what that told us is that for future code cycles, we will need to go into those committee discussions with a goal in mind, and we will evaluate each amendment under the umbrella of how might it contribute to that overall goal. Is it part of that easiest path to get to that overall goal, but we will need to work towards that goal. And that will mean close collaboration with the community, and it might mean extending greater resources to the community to be able to perform to meet these more stringent code requirements. We'll also continue to use the Denver Green Code. It's a voluntary code. There are incentives that are offered right now for teams who choose to use it, expedited permitting and reduced permitting fees being the key ones. It's an opportunity for teams to be leaders in the community, but it's also an opportunity for every other team to see the topics that we think are probably most viable to be moved into mandatory base code in the next code cycle. That's a huge opportunity because we are going to be pushing our energy code 10 to 15% for an improvement of 10 to 15% at each code cycle, which is pretty aggressive. And knowing what's coming before it arrives is going to be really valuable to the development community so that everybody can succeed instead of being caught off guard when something becomes mandatory. So I'm not going to talk about the opportunities. I think everybody knows the general categories of the IECC amendments target. The Denver Green Code targets similar built outcomes, but just more holistically from a sustainability standpoint with energy embedded in there. The Denver Green Code is chapter specific to each one of those different topics, so energy, water, waste management, operations is in there, what happens on the construction site is in there, so it really expands that window to start looking more broadly. There are prescriptive or performance tasks. Everything is achievable in Denver. The community works really hard to make sure that the Denver Green Code is achievable in Denver. There are 4 possible compliance pathways under the Denver Green Code, and there's a huge look toward energy efficiency and just energy use. So there's a big focus on that because we know that that's important to Denver's future. The Green Buildings Ordinance is always being considered in conjunction with these amendments that we're creating. Any project that complies with the Denver Green Code is considered automatically to have satisfied requirements of the Green Buildings Ordinance. The Green Buildings Ordinance, just as a little refresher, applies to any building 25,000 square feet or larger. It's mandatory. It was brought to the city by the voters. And it is super achievable for mainstream buildings. It provides modest achievement above base codes and focuses on holistic sustainability and energy efficiency mostly, as well as provision of equitable green space around our city for everybody and renewable energy provision. So we are using the Green Buildings Ordinance right now to try to close the gap between predicted energy use and actual energy use in buildings and to get our buildings performing the way that we predict. We're doing this because we're seeing from anecdotal spot checking that buildings are using 2 to 4 times as much energy as they're predicted. That's not because those teams are bad. That's because it's really complex to try to get an energy model up front that predicts the actual use that the building winds up resulting in. But since we have the benchmarking ordinance, we can do that as teams. We have the data, and that's a great tool to help support us in achieving Denver's goals, the goals that the community has brought to us, and in preserving just the basic health and welfare of all of our citizens. So it's important, again, to stress that we view equity, affordability, and sustainability as one goal. We cannot achieve one piece of that without achieving all 3 of those pieces together. We're collaborating across a whole list of agencies within the city, and our work involves this net zero energy new buildings implementation plan, but also a whole bunch of other stuff that's going on. We're looking at new buildings, but we're also looking at sites and existing buildings and the district scale, the neighborhood scale, the city scale, and we're looking to our project teams to start collaborating more and communicating more within the team, with the city, with the owners, with the occupants. It takes all of us to get to successful outcomes, and we have to measure. We have to look at the metrics, and we have to be accountable to get to successful outcomes. If there are other things besides codes that come to mind related to raising the bar on energy, know that we are looking at other things as well. I'm not going to talk about all of those, but there's a lot of work that goes into supporting the code work. We're looking at planning opportunities. We're looking at sustainability beyond energy. So all of it is really just to support the future of Denver and the future of our occupants and the future of our lifestyle and everybody's resiliency here. So that's kind of the overview. I want to make sure everybody knows that Keith Fox on our team has stepped up into the position leading our IECC review team internally with our plan reviews and with our inspections team, and externally with the community providing interpretation and support with the code. So his contact information is here. I am also collaborating with him on a lot of this work related to the Denver Green Code and on IECC conversations and on the Green Buildings Ordinance and all of these big future goals. So my information is here as well. And with that, I will hand it back.
Thanks, Christy. So now I'll go ahead and pass the presenting rights over to Kevin. All right, Kevin, you should be set there. So we're going to jump into the Denver amendments portion of the presentation. And again, if you have any questions, please write in the the chat throughout the presentation, and we'll answer the questions at the end. Today, our presenter is Kevin Perry, and Kevin is the Manager of Engineering Services at NORESCO and a certified commissioning professional with over a decade of experience. He is also a plans examiner and inspector for the IECC and ASHRAE and sits on the 2018 IECC Energy Task Force. He has provided over 100 trainings on IECC to contractors, architects, engineers, and code officials. So with that, I'll let Kevin take it from here.
Thanks, Erica. I hope you can see the correct screen I have up. Should be a picture of myself. I don't have my webcam on, but if you wanted to see what I look like, if you aren't sure, this is what I look like here in a suit jacket. But thanks, Erica, and everybody for joining this training. The agenda for today is to really discuss the changes from the 2015 IECC to the 2018 IECC, along with the amendments that the City and County of Denver had made to the IECC on just the mechanical section and the plumbing section. Now, this training was originally set up for geared more towards the city's officials, such as plans examiners and inspectors. However, it's been opened up to everybody in the community, AEC community, to benefit from this and ask questions so everybody's on the same page moving forward. Later on in the week, we will be discussing the same agenda, but from an architect's perspective. So if you want to tune in on Thursday this week, you can hear that. So just, just a brief introduction on things. The intent, I try to start with, kind of easing into the code and things. It's a very technical document, and we try to make it a little bit more user-friendly or easier to understand. So just kind of some intent of the code is to, regulate the design and construction of our buildings here in the City and County of Denver. And the reason for that is exactly what Christy mentioned. It's the conservation of energy. The city and county has goals. They have the 80 by 50 goal, and they have their zero net energy goal for all new buildings by 2035. And so in order for us to hit those goals, we need to make sure that we're conserving as much energy that we can over the life of each building by regulating the design and construction of these buildings. And the other thing for that, the intent of the code and the city and county is to provide flexibility. Some of the best innovative approaches that, that we've seen in the world is because of flexibility. So we don't want to limit what people can come up with just because the book says it's supposed to be like that. So I think the city and county of Denver did a really good job giving everybody several different pathways and flexibility through the code to help us get there. Now, with that comes ways to maybe game this system. And again, the city and county of Denver did a good job on looking at all these different pathways of compliance and tried to figure out, it doesn't do anybody any good. Maybe up front, the upfront dollar cost, for someone to game the system, but it doesn't do us good as a whole if you're gaming the system to get to our goals. So people ask, all right, is this just for new construction? Well, the code is based on new construction and existing buildings. So what's great about this, it's simple. If you have a new construction or you're adding on or doing a TI or changing the use of or occupancy, you're altering a space, you got to comply with the code. Anything you touch, basically, is a simple way. Anything you touch has to be brought up to code. That's the easiest way to think about it, no matter if it's a new construction or not. If it's a quick repair, like you had a broken light fixture, and you just needed to put a new light bulb in, okay, you don't need to bring that whole light fixture up to code. That's just a simple repair. But if you're looking at touching something that is covered by the code, then you'd have to bring it up to code. And with that, here are your different compliance pathways just for the City and County of Denver. So we're focused on that for today's presentation. So you have the IECC, and then you have the AHJ, which is, in this case, the City and County of Denver. And they have their own requirements. So each one of these colored boxes are events or pathways or options that or even mandatory requirements that the City and County of Denver has come up with, and even the voters. So it started with Energize Denver, where where buildings have to rate and report their energy use, and that was kind of step one of knowing where the city's at, benchmarking to get us to where we need to go to see how far off we are and what we need to do. Then you have the Green Building Ordinance, which was voted on by the voters and approved, which has its own pathways. You then have the Denver Green Code, which is a stretch code, which is above and beyond the current code. And then you have what we're going to talk about is the IECC on that. But with that, as you can see, each one of these has their own pathways. And if we're following the IECC, it says we can follow ASHRAE 90.1 as well. And then each one of those have their own pathways. So you can see this tree can get pretty wide pretty quickly. And, this is that flexibility that I talked about a couple slides ago, which is great. However, for code officials in the city and county, they probably have it the easiest in remembering all these different pathways just because they only have to worry about the City and County of Denver. Where if you're part of the AEC community, they have to know all the different cities and counties and AHJs throughout the state. Since it's a home rule state, there's close to 300 different AHJs, all having their own amendments and their own pathways and things like that. So I know you probably don't think this, but City and County of Denver code officials actually have it a little bit easier than the rest of the community from knowing this is all I need to know, even though there are still a lot of pathways that they still need to know and be educated on. So if we're talking about the IECC, there's really 4 ways to comply with that. And this is, it just has to clearly be indicated on your drawings. And what that's saying is basically you have the IECC pathway over here on the right, following 2018 codes, or you can follow the ASHRAE 90.1 2016 version and following that booklet. Either way, you have other options. So here are your 4 options: your prescriptive, performance, Appendix G, and prescriptive under ASHRAE 90.1. So when I say there's 4 compliance paths, that's what I'm talking about when you're looking at that. And so you might ask, all right, well, how do we know that? Well, it should be on the plans on which pathway they're going. And when a new building comes in for permit, whatever pathway they select for that building for the life of it has to follow that pathway. So for instance, if someone picks ASHRAE 90.1 2016 Appendix G as their pathway, that is the pathway that they have to follow, whether it's core and shell, and then maybe next comes a TI. Maybe a TI only for 2 of the 12 floors. Those 2 of those 12 floors still have to follow Appendix G, and then when the other 10 of those floors get finished out, they also have to follow Appendix G pathway. You can't mix and match. And the reason we do that is because each one of these pathways are not equal in terms of energy usage. And so if you jump and skip from one pathway to the other, we're really not doing any favors, again, on getting to our energy goals by jumping and skipping and saying, oh, I'm going to take the lighting from this pathway and the mechanical from this pathway and the domestic water heating from this pathway, because they're all different. And so the City and County of Denver and the task force that I sat on, we looked at these pathways to try to shore them up, to make them a little bit more equal, because right now, as it stands, they're not quite equal. As you can see, the IECC, if you do a model, it has to be 15% better than code, whereas if you did a model, which was, an option that's not listed here because Denver took it out, it just had to be better than code. And so you can see that, all right, IECC, you actually have to do more in IECC if you follow that pathway, because you have to be 15% better than code. But if you did a model in the ASHRAE side, you just have to be better than code. So Denver shored that up, and in doing that, they got rid of a modeling pathway in ASHRAE and came up with a different modeling pathway, which is Appendix G, following ASHRAE, which is great. That's, oops, sorry, wrong slide. It's great because that also follows closely with some of the other programs in and around City of Denver. So, for example, the LEED rating system, if you're familiar with LEED, the USGBC's LEED rating system, they follow ASHRAE 90.1 modeling, Appendix G, and so does Xcel Energy's Energy Design Assist program, which is a modeling program where you can get funding based on your design. And that's using ASHRAE Appendix G. It can be using Appendix G, but it uses ASHRAE for it as well. So it kind of lines up good with that. In my opinion, I see more Appendix G models than anything else in any of these four pathways, just because of, you can get points for LEED certification, and you can get some funding for from Xcel Energy on Design Assist. So just my opinion on that. And the other thing, a couple things I want to point out on this compliance chart here. You got mandatory sections no matter which pathway you go down. You have to do those, and we're going to cover those today. And then this pick one over here on the right side, Denver has amended that in Section 406 that they actually want you to pick two on that, which is helping even things out from the IECC side to the ASHRAE side. And then the last thing I'll point out is on the Appendix G, better than baseline, that is been amended by City and County of Denver to say, actually, it's got to be 5% better than baseline, which, that's good, because if you keep it in mind, LEED will give you up to 10 points. If you're anywhere from 10% better all the way up to, 42% better. So if you're meeting the cities, or if you're trying to go after LEED and you want to get some points, the minimum number of points you have is is 10%. And so that would automatically get you to meet the Appendix G better than 5% for the City and County of Denver. And Xcel Energy is better than current local code. So it lines up pretty good. So we'll, real quick, if you're following the performance side, anything in red is new, mandatory requirements for the City and County of Denver. So we're going to focus today on Section 403, which is mechanical, 404, which is domestic water, which is the plumbing side of this, and then Section 408, commissioning, because commissioning touches mechanical and plumbing on that. On the prescriptive side of things, you can see the only two things in red are the pick one option in Section 406. They've added two more requirements there, enhanced envelope and reduced air infiltration from the last code cycle to this code cycle. Remember, Denver is making you pick two in this category now. You now, instead of 6 options, you have 8 options to pick from, and you have to pick 2 of those. And you'll notice nothing else in here is red, because prescriptive follows the book by the book than anything else. So that's why things aren't red. So let's jump right in. Try to make this not boring and reading from the slide. I know code can be daunting, so just bear with me, and we'll have some examples and things like that to kind of keep things moving. But if you looking at IECC only mandatory items, so if you're following the IECC pathway and you're looking at mandatory items, these 6 items are mandatory if you're following IECC. No matter which pathway down IECC, these are the things that you need to look at. Boiler setback, ERV, exhaust system, horsepower for your motors, your duct sealing, and pipe insulation protection. On the ASHRAE side of things, so if we go to the left side of that flow chart, if you're following any one of those pathways, those 2 pathways, these are the mandatory items that you need to follow. There's requirements for humidification, dehumidification, that can't happen simultaneously. You need to monitor your chilled water plant, and you need to have at least R3.5 in your radiant floor heating system. So those are the mandatory items if you're following either or pathway. So what about if you're following either pathway? So no matter what pathway you follow, these are the items that whether you follow ASHRAE or IECC, you have to do no matter what. So the last slide, we're talking about ASHRAE only. The slide before that is IECC only. But this one is no matter what pathway, you got to follow these items. So we're going to jump into those items. There's just a lot on there. And I'll just tell you right now that these are mandatory items. They're not new to the code. They're only new because they're now required, no matter which pathway you go down. They were in the code the last code cycle, and most of the things haven't changed, but now that they're mandatory, people have to do these, so people are now starting to have to pay attention to these items. And we're going to go through those. So section 403.2, not new, it's just mandatory no matter which pathway you go down. You need to have zone isolation for your mechanical equipment. Okay, no big deal. Easy way to remember that. Each floor plate needs to have its own zone. So if you have 2 floors, each floor needs to be on its own zone. So you'll just need to have some type of isolation damper between floors or somewhere that can isolate one floor for the next. Or if each floor plate or area is bigger than 25,000 square feet, it needs to have its own zone. So if you have a 30,000 square foot floor, then at a minimum you would need at least 2 zones for that floor. So you need at least one damper in there to isolate the zones from each other. The reason we do this is based on energy consumption. So they found out that, if floor 1, is occupied from 6 a.m. to 5 p.m., but floor 2 isn't occupied until 9 a.m. and goes till 6 p.m., why are we going to heat and cool both floors when, there's 3 hours in there that the one floor doesn't need to be heated and cooled, and we can conserve energy a little bit more by having the zone isolated and not cooling that entire space. So those are the not new requirements. Those are now the mandatory items that need to happen. So it's easy to do. The other thing on the screen here, ventilation needs to be per the International Mechanical Code. Again, nothing new, but just now mandatory. So how do we look at this from a plans reviewer or a field inspector? With that, it's pretty easy on plans to just try and find a damper, a zone isolation damper. Doesn't have, your plans aren't going to be color coded like this per se, but just on plans you can look for a damper and kind of do a rough square foot calculation. If it's 25,000, 2 square feet, I'd say pick your battle on that. I think there's some other things that are probably a little bit more pressing that would call out, but if it's 30,000 or 35,000 square feet, then I might call out, hey, you need to have this split up into two zones. But pretty easy to find a damper on the plans on that. And then in the field, same thing. If you saw the damper on the plans, just go to that location and find that damper in the field. And this requirement then is marked off as being complete, as mandatory requirement. So next section, 403.3 and point 2, again, not mandatory, or sorry, not new, just it's new in the fact that it's now mandatory, is equipment site load calculations. Load calcs are needed to know the output capacity of both your heating and cooling sizing on that. And I would recommend looking for those load calculations or requiring those on your set of drawings or putting those on your set of drawings. That way it's very easy for whoever is reviewing these to look at the load calculations and say that you meet the requirements and basically you don't exceed what you need. That's a saying that you can use, that if we only need 2 tons of heating and cooling, or so let's say if we need 10 tons of heating and cooling, why would we put 15 tons of heating and cooling in a building when we don't need that? So we want to make sure that we get as close to that 10-ton mark as possible on that. So just saying the next smallest available size is what should be used. And then equipment performance has been updated. I didn't put those in this presentation because there's several pages on that, but depending on what type of equipment you're using, the performance of that equipment has probably gone up, or could potentially have gone up from the 2015 code to 2018. So if you got 1 ton of BTU, 1 ton is about 12,000 BTUs. And your calculations on your plans show that you need 25,000 BTUs for heating or cooling. So how many tons should the unit be? So again, the code says we don't want to exceed more than we need. So if we have 1 ton at 12,000, you can do the simple calculation. I'm giving you a couple seconds to do that math. But the answer should be about 2.5 tons. So 24,000 BTU would be 2 tons. Well, we need a little bit more than that 2 tons. If we go up to 3 tons, which is 36,000, we're exceeded the next lowest level. Because they make 2.5-ton units, we would select, or someone would need to select, the 2.5-ton option and not the 3-ton option. So this is just an example, a quick, simple example of when you're doing your reviews that you can do. Just look to see how many BTUs are needed for the heating and cooling, and do the simple calculation. And sometimes, the larger the units get, less range they have in terms of half a tonnage or 1 ton availability. So if you get up to a 50-ton unit, they might not have a 50.5-ton unit. They might not even have a 52-ton unit. The next available size might be a 55-ton or a 60-ton unit. So just keep that in mind when you're doing this review, that the next available size closest to the tonnage needed is what you're looking for. So these are the tables that I was talking about that have been updated. You can see not a whole lot has changed on closed circuit cooling towers between 2015 and 2018. We went from 14 GPMs to 16.1. And if you compare that to the ASHRAE pathway, IECC and ASHRAE are the same there. And Denver didn't change any of that. So Denver said, all right, whatever's in ASHRAE or IECC, we're good with. The other big change that I think are, I just kind of pointed out the 2 that are probably the most common that we'll see here around Denver are warm air furnaces. It went from 78% to 80% in IECC. But if you're following ASHRAE, it's still 78% AFUE. So not a whole lot of changes, but just know that there have been changes in these tables, and it would be good to have those handy when you're doing your review. Section 403.4 is a big section. It's on controls And this is the primary, this is where we see a lot of energy efficiencies on our control systems. You know, we can only do so much from an equipment standpoint on getting the efficiencies as good as possible, but really where the rubber meets the road here is based on your controls system and how things are being controlled. And this can be tricky for you all as planes examiners and inspectors, being that control is a lot of the time based on functionality. And, you know, most of you will say, well, that's not my job or not my place to be testing the functionality of these systems. I need to make sure that they're, you know, designed to code, they meet code, and, you know, that's it. So I would say that the commissioning agent is your best friend, because the commissioning agent will actually, their primary job is to actually test these systems and these controls to make sure they're operating as intended per the design. So we'll get into this a little bit later in the presentation, but the commissioning agent, Denver has made an amendment to actually have the commissioning agent give you all the reports of their findings and their tests, how they did their tests, and their issues that they found during their tests as part of their preliminary commissioning report. So that allows you all to kind of do your job better in that aspect of, hey, I didn't have time to functionally test it. I can heavily rely on the commissioning agent's report to review this, and we can go from that aspect. So Denver amended that section to help out with that. But we'll get into more of the commissioning side later on. So with controls, again, none of these are new per se. The one thing that's new is highlighted in red. These were in the old code, but we'll go through them real quick just because they weren't mandatory before, but now they are. So you're probably not familiar unless you've seen these before. So thermostatic controls, basically it's saying each zone, remember we talked about, you know, the mechanical systems being split up into zones per floor plate or square footage, needs to have its own control system. And so that's easy to do on the plans and in the field. All right, make sure that each one has a thermostat in that area, and that would work. Now they could be controlled via BMS, you know, building management system, but you know, an easy check is just to look for thermostats. Heat pump, supplementary heat. Basically, that's saying if a heat pump is equipped with electric heat, supplementary electric heat, it needs controls to not allow that to be the primary source of heating. So, you know, electric heat is probably, well, it is more expensive than having your rooftop unit or bigger piece of equipment if it's going into this heat pump and already having some heat put into it, provide the heat then to have the system provide electric heat. That's almost like a backup system, if you will. You know, in case we can't get to what we need, then this electric heat kicks on to get us there. But what the code is saying is we don't want that to be its primary source of heat because that's not as efficient. It's not the most efficient way to control that heat pump. So we need to make sure controls has that in there. Deadband, real quick on that, it's saying deadband has to be 5 degrees or greater. And so that's saying that you can't, it's preventing heating and cooling from kicking on very quick. So that's 2.5 degrees on each side. So if you're in an auto mode, you know, you don't undercool the system and then, oh, I got to hurry up and turn the heat on because we're too cold. And then the heat comes on and you overheat the zone and, oh, we now turn on the cooling because it's too hot. So that deadband allows for that to not happen as frequently and hopefully not at all. So 5-degree deadband. Then the next thing is set point overlap. You know, this is just if the zones have if your zone has a separate control setting for cooling mode, a separate control setting for heating mode, this is what that's for. It's just saying that those need to make sure a deadband is programmed between those two controls. So that's not too common, but it's in the code. And then the last thing, which is the new thing to the code that we have, is heated and cooled vestibules. This is new in the fact that if the outside air is over 45 degrees, so that's it turns off the heating ability in that vestibule. So a lot of times what we'll see that I see in the field is that you just have this kind of in-wall heating unit heater for the vestibule, and there's a little thermostat in there, and that thermostat is set to maybe 70 degrees to keep that vestibule warm. And when the door opens, cold air comes in, whatever, it does its job. Well, it's saying that now you can't just have a thermostat. You actually need to be based on outside air temperature. So if it's over 45 degrees, we aren't going to allow heating in that vestibule. The other thing is the thermostat needs to be able, it can't heat over 60 degrees. So why would we need that vestibule to be 70 degrees when there's not occupants regularly occupying that space? It's just a transition zone. When we can reduce the amount of energy consumption, it's saying that if we only allow it to get up to 60 degrees as its max temperature, that is what's required on heating mode. From a cooling standpoint, it also says 85 degrees. So we can't cool it lower than 85 degrees in that vestibule. So that's new to the code. So how do we make sure these controls are in place from a plans reviewer and from a field inspector? Well, I think step one is having the requirement of the sequence of operations listed on your plans. So if the sequence of operations are not listed on your permit set, then I would go ahead and make a comment and say those are mandatory. And that way you can look to see if some of these items, you then can pick and choose which ones you want to check, but you can say I want to check deadband. So do a quick cursory review just to make sure there's a deadband sequence in there. It takes, just look for the word deadband and you're good to go from a plan standpoint. In the field, that's a little bit more complicated. I think there are some things that like thermostats you can look for, dampers, things like that. But I think that, functionality, you're going to have to rely on the commissioning agent's report. So more controls. None of this is new, but it's now mandatory. So we'll go to it real quick. Off-hour controls. So remember, each zone we talked about previously needs to have a setback via time clock or programmable control system, so like a BMS type system or DDC, whatever you want to call it. Thermostatic setback. This is basically a temporary setback to maintain temperatures from 55 to 85. How do we check this? Okay, well, we can check it via inputs on your model. So say someone's doing a model instead of a prescriptive pathway. So you can check that. These are one of the inputs on your model are thermostat setbacks. So just check to make sure those setbacks, those inputs are set to 55 and 85, and you're good. Automatic start. This is basically, looking at the schedule. The schedule needs to be for 7 days at a minimum. You also need to be able to manually override the system. So basically, for 2 hours. So basically, if the building's in unoccupied mode and someone comes into work for the day, they want to, instead of turning on the entire system, you can just turn on that zone with this automatic setback for 2 hours without having to turn on the entire system. And then after 2 hours, then the system would turn back off. So that can be tied to an occupancy sensor or to a schedule manually or to an occupancy sensor. So we can do that. Automatic start This is also known as, you might be familiar with this, as morning warm-up or morning cool-down. This is just to get the building to occupied temperatures prior to occupants getting there. Can slowly ramp up instead of blasting full force right when, 8 o'clock comes and everybody gets there. It can slowly get there. That's what that automatic start is. It's also something that you can look at in the model as an input to make sure that's in there. The last thing on the slide is hot water boiler setback. So this is based on outside air temperature. So your boiler actually needs to be set back. If it's warmer outside, you probably don't need as hot water going into your heating system. So you would set that back and conserve energy. The code, however, does not say there are no restrictions in the code on what that setback is. So it doesn't say, all right, if it's 90 degrees outside, then I set back my temperature to 140 degrees or anything like that. It just says you need to have some type of setback programmed based on outside air for a boiler, hot water boiler system. And this is the last slide on controls. Like I said, this was a big section, controls. Nothing's new. It's just now mandatory. There are some things that you need to have. This is more from a hydronic section or standpoint. I won't go into this too much, but just know that there are items for hydronic controls, which again, you can look for some of these things based on plans, looking for valves, isolation valves. You can look at, around the pumps and things like that. But we won't go too much into that. So let's go to the next section on economizers. This is a big change from Denver's last code cycle. It basically said any equipment capable of cooling would need to have an economizer, which that's a pretty big change. That was from 2009 to 2015, but now we're going from 2015 to 2018. And they updated that to say economizers are no longer required for all cooling equipment. It's now based on these three factors, your chilled water capacity, your fan cooling capacity, based on R group or non-R group. And so if your chill water capacity is 1.3 BTUs per hour, then you need you need an economizer program. If you're for non-group Rs, the threshold is 54,000 BTUs, and then for R groups, 270,000 BTUs. So quick check on the plans. Check to see if it's group R or non-group R, and then look at those values, 54,000 or 270,000. If it hits those thresholds, that piece of mechanical equipment needs to have an economizer. So that's pretty simple check to do. So how do we do that? If it doesn't say it, we can look for an outside air duct, some dampers, things like that on the plans. We can also do that in the field as well. So economizer, for those of you who aren't familiar with it, economizer is like a free cooling. If the temperature and humidity is right, it'll open up the outside air damper more and bring in that cooler, less humid or humid air, and use that as cooling instead of using mechanical cooling. So it's an energy saving operation that it saves quite a bit of energy. So if you do have economizer, you need to have fault detection and diagnostics as part of that economizer. So not new, but it's now mandatory. And what that is, so what you need are 3 sensors. Again, you can look at this in the field and or on plans: outside air sensor, a supply air sensor, and return air sensor. And then you need to have the status of some equipment. So this will be from a control standpoint. You need to have, you can look at your inputs from your sequence of operation and look for free cooling. I won't go through all those. I won't read those off, but you can see those on the screen. But those are your control system, whether it's on your unit itself or at the building level, will need to be capable of reading the status of those items listed. And then your unit or your building level control system has to be capable of detecting those 5 items, whether it's an air temps fault, sensor fault, if it's economizing when it shouldn't be or should be and it's not, if the damper's not modulating, if you got excess outdoor air when you're not supposed to, things like that. So that's your fault detection and diagnostics if you have economizer on your piece of equipment. Demand control ventilation. This is for spaces that have higher occupancies at different times of the day. We're bringing in more outside air to meet the IMC and things like that. So it's saying that you need demand control ventilation if the space is greater than 500 square feet and your average occupant load is 25 people or more per 1,000 square feet of floor area, and if the system is served by one of the following. It has economizer mode. It has an automatic modulating damper, so basically an outside air damper that modulates, or if your design airflow is greater than 3,000 CFM. So pretty simple to look at. Look to see if you need an economizer based on our previous slides, and then look to see if the space is served larger than the square footage and the occupant level on that. Now, there are some exceptions. If the system has the energy recovery ventilator, then you don't need to have demand control ventilation. Systems with outside air less than 1,200 CFM, you don't really need to have demand control ventilation, or if ventilation is for process loads only. So those are probably there are some more exceptions, but those are probably the 3 most common ones you'll see on there. But another way to check to see if demand control ventilation is in place, look for CO2 sensors on the plans. That's probably a good starting point, or even in the field, look to see if the space has CO2 sensors, and that will be a starting point. Doesn't mean it's actually programmed and operating correctly, but if they have that sensor in there, more than likely they probably have some type of demand control ventilation. So this is a Denver amendment only. This is not part of the IECC or ASHRAE per se, but Denver has added a section, 403.711, brand new section to Denver, in Denver only. And it's saying that if you have a single zone VAV system or a dedicated outdoor air system, an energy recovery ventilator, or a makeup air unit, then you need to have controls for outside air. You need to have fault detection on excessive outside air. It must report to the building automation system, or DDC, direct digital controls, and needs to be able to measure and maintain flow rates, which are referenced in the IMC. So does that sound familiar? Remember this? We have outside air and excess outdoor air. That was on economizer fault detection. Well, that was for economizers, equipment that had economizers. Well, this is saying these 4 other pieces of equipment, whether it has economizer mode or not, will need to have some of these things. So this is a big change, the Denver Amendment. And this is, being that ComCheck and some of these other modeling softwares don't have our Denver amendments incorporated into them yet. This could be a little red flag section where people are getting away with not having basically airflow monitoring stations and fault detection on some of these things because it's not being caught in the software yet. Once the software is brought up to speed, then it'll flag it, that it needs it. But until then, this is something that we need to keep an eye on, that DOAS units, ERVs, and MAUs, makeup area units, need to have basically flow monitoring stations on them. And then any of those systems, if they have outside air over 4,000 CFM, then a flow monitoring station is required at a minimum. So the 4 bullet points before, you can get away without using a flow monitoring station. It's basically the same thing. It's giving people flexibility to monitor the outside air flow without having to use a flow monitoring station. So they can use controls and sensors, other sensors to do that. It's the same exact thing. It's just giving flexibility to people whether or not they want to use a flow monitoring station or not. Some people argue that flow monitoring stations are expensive, and so they want to go the first route where the first 4 bullet points will meet their requirement instead of a flow monitoring station. But if you're over 4,000 CFM of outside air, you have to have a flow monitoring station. And just a little background on this is the reason for this is that if we bring in excess outside air and it's not at the right temperature or humidity levels, we're now having to use more mechanical heating and cooling to get that air where it needs to be. So therefore, we're using more energy just because we're bringing in more outside air than, because they're not perfect conditions for what the space needs. So this is an energy savings measure that, yes, at certain outside air temperature, it actually saves us energy to bring in more outside air. But if that outside air temperature is not at the right level, then it actually could be costing us more energy to get that where it needs to be. So this is an amendment to Denver that we would need to keep in mind. So ERVs, Energy Recovery Ventilator, this is a Denver amendment. Well, I'm sorry, let me back up. This is not new, but Denver has amended these tables below. And they changed to include both outside air and exhaust air. It was just exhaust air on there, or supply air, sorry. So if the outside air exceeds the table values, then we need to have, the equipment needs to be equipped with the ERV. Or if the exhaust air exceeds 3 times the table value, then the piece of equipment needs to have an ERV. So pretty simple to look at the plans. You'll look to see how much outside air is being brought in, and you'll look to see if it exceeds the table values based on, the top table is based on, operating hours, less than 8,000. The bottom table is if it's operating more than 8,000 hours per year. So if it exceeds the values of the tables, then we need to have an ERV system as part of that mechanical piece of equipment. Pretty easy to check from a plan standpoint. And then ERV basically, it does the same thing as what we talked about in the past slide, economizer, except for it has a heat transfer mechanism, whether that's a wheel or a box that has air flowing through, filters, things like that. But ERV basically saying if that piece of equipment based on these tables needs an energy recovery ventilation system, then that system needs to have bypass dampers both on the supply and exhaust side. So pretty easy to see on the plans, pretty easy to see in the field too. You pop your head in the cabinet, look to see if those dampers are in there, and you're good to go. Now, they could do the other option, which controls the operation of the economizer. So they need the bypass dampers or controls that permanent operation of the economizer. This photo here is a energy recovery wheel. We see these quite a bit on rooftop units. It's a big wheel that, heated air, tempered air from the building passes through this wheel, and the wheel spins, and as outside air is bypassing it, it actually has some heat transfer, and then less heating and cooling, or even no heating and cooling, needs to be done before it goes back into the building. So instead of wasting all that already tempered air and going straight outside, we're actually using some heat transfer to recover some of that energy. All right, section 403.8.1, fans and fan controls. This is not new, but again, mandatory. That's why we're going through it. So you have to follow all three of these things. Just a background, horsepower is the motor size. That's a function of brake horsepower and efficiency, so all these kind of play on with each other. So any fan in the HVAC system needs to follow this. And it's based on their size. So the horsepower option, any fan, 5 horsepower and greater, can't be excessively oversized. So at the table down below, you'll see what that means. You'll look on the plans on the mechanical schedule and look to see horsepowers for that equipment. Look to see if it's constant volume or variable volume, not too far off from each other. So don't worry about if you can't find that. You're probably going to be pretty close if you're doing the math. But multiply your CFM by the value there, 0.0011 or 0.0015, and that should give you your horsepower needed on that. And we just can't be excessively oversized, quote unquote, excessively. Code doesn't say what excessively is. I'll leave that up to your judgment on what excessive is, but you'll probably have a good idea when you see it if it's excessive. Then you have your brake horsepower. So for brake horsepower, for brake horsepower 6 and less, 1.5 times, and brake horsepower 6 or more, 1.3 times is what you're looking for on that. And then fan efficiency needs to be at least 67% or better. In the field, you're just going to look at the nameplates, horsepower, brake horsepower, things like that. Make sure it matches up with the plans. For those of you looking at the plans first, you're the first line of defense to make sure it's not excessively sized, because when your cohort goes in the field to look, they're going to take the plans and assume that that has already been checked. And they're going to look on the plans to see what it needs to be and matches up. Okay, what about fans that are 12 horsepower or less? This is a new section for Denver only. This is not part of code, but Denver has come up with this. This is easy to spot check on plans. So any fans that are 12 horsepower needs to comply with this on efficiencies. So pretty easy to do. Just use this table, look at your schedule on the plans, boom, 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 done. 1.2 watt per CFM per watt, so you're good to go, things like that. All right, now we move into refrigeration sections, which I know this is from a mechanical standpoint, but there's a lot of mechanical equipment in refrigeration, including compressors and things like that. So that's why we're talking about it. even though all these items here don't necessarily fall into the mechanical realm per se. Maybe they do. I don't know what the city and county does. I don't know who's required to look at refrigeration, if it's the mechanical people or not, but we're going to talk about it so you're equipped with it just in case. Again, not new, but you know, we in the last code cycle, it was the first time that we talked about actually setting requirements for walk-in coolers and refrigerators and freezers and display cases, because they actually use quite a bit of energy. And so that was the introduction, was the last code cycle. This code cycle, it's now mandatory. And you'll kind of see that as a reoccurring theme in the different codes, that things get introduced in one code cycle, and then the next code cycle, they become mandatory. So if you want to get ahead of the game, just look to see what's been introduced in the code cycle is new, and then more than likely the next code cycle is going to be mandatory. So anyway, what it's saying is basically walk-in coolers and freezers and display cases, things like that, need to have automatic door closers. It's not a mechanical thing, but you know, it affects the mechanical systems. Easy to check on plans, easy to check in the field. If you're walking by, just make sure it has a door closer. Then you need, you know, R25. So in the walls and ceilings, it needs to have R25. The doors, R32. And on the floor, R28. Something you may or may not, that might be more on the architectural plans reviewer side, but I don't know who's required to look at that, so I'm just kind of equipping you with that. And then the doors, if you have transparent doors, they just need to be triple pane and filled with an inert gas, or have a heat reflective treated glass. So that's kind of new. Kind of hard to check in the field. There are ways to do that. I won't tell you how I do that because it's probably not advised, but I can, if you want to chat with me on the phone or email, I'll tell you how to check that in the field. And then the last thing is that the lighting, you know, you can't have more than 40 lumens per watt, and you need an occupancy sensor to turn off that light. So that's pretty easy to look by, you know, on the plans and in the field. Just make sure there's a timer or occupancy sensor for these type of systems. So moving on, ducts and plenums and piping. So supply, return ductwork and any plenums, whether it's supply or return plenum, need to be insulated. No matter what, if it's supplying air, returning air, or if it's a plenum, it needs to be insulated. And the insulation value is R12, no matter the location. You know, if it's supply, return, or plenum, it needs to have R12. And then pressure classification, I won't go into that, but high pressure duct systems, you know, that's 3 inches of water column or greater, must be leak tested and pass. So you don't need to test the entire duct system, but at least 25% of the duct area needs to be tested and pass the leakage rate. So who's going to get that report? Do you all get that report? Does the commission agent look at the report? I don't know if you guys get the report, but I know the commission agent usually doesn't get the report. It's usually not in their contract to look at that. So this might be something to keep an eye on. If you have a high pressure duct system, to keep an eye on or make sure that pressure testing has been done on that. And then piping, insulate, you know, your piping for mechanical equipment, it's what we're talking about, has to be insulated. You know, it has to be protected from weather. So sometimes you see that white plastic covering on that. That's an easy way to look in the field. It needs to be on that. So how much does it need to be insulated? Your HVAC piping, you know, it's based on the temperature of the fluid in the piping. You know, we're looking anywhere from 1 inch to 5 inches of thickness. So you can look at that. All right, let's move to HVAC outside of the building now. We talked about HVAC inside the building. You know, we think about we're going out to eat and it's kind of chilly out, and we have these radiant heating panels and these, you know, these dining areas outside, you know, like the patio seating. Those are great. I love them. But they do use energy, and they need to be controlled. So they either need to be controlled by an occupancy sensor or by a timer. So those are your two options when you have these systems outside. Pretty easy to check on plans. A little bit more difficult to check in the field. You just need to know where those sensors are or where that timer is. But basically, we don't want to be heating that space or wasting that heating electricity when no one's around. And so that's the intent of that one. Then outside of the building HVAC, we look at snow melt systems. Snow melt systems need to have automatic controls to shut off, which makes sense, and you know, it's not new, it's just mandatory now. So when it's 50 degrees outside, when the pavement temperature is 50 degrees and above, and precipitation, so it's not raining or snowing, you need to have an automatic or manual control to shut that off. So basically, you know, if the pavement temperature, you look at pavement temperature and outside air temperature, that will determine whether or not the system should be running or not. So if the outside air temperature is above 40 degrees, we don't need the snow melt system on. You know, so that's what we're going to look at. It's a control set point there that we're going to look at. Commission agents more than likely will look at this, but not necessarily. It's depending on the size of the equipment that it's being. If it has its own boiler, then potentially it might get skipped from a commissioning standpoint. But if it's tied to the boiler for the rest of the building and has a heat exchanger, then more than likely it will get checked by the commission agent. But just know that this is an area that could get overlooked if you're relying on a commission agent to look at it. And then freeze protection. Heat trace is needed to shut off when outside air is above 40 degrees. So we're just making sure that, you know, we're not wasting electricity or heat or whatever on freeze protection when, you know, there's no chance of freezing above 40 degrees. So that's what the code says, and that's what is mandatory now. All right, this is the last slide for the mechanical portion, and then we'll jump into plumbing. Plumbing, I'll tell you, is very, very short, just because there's not a whole lot on there. So we'll just wrap up the mechanical section here. And this is Denver amendment only. This is new to Denver, City and County of Denver. So for plant growth and maintenance facilities like that, cooling efficiency and dehumidification requirements now exist. We're seeing that quite a bit of energy is being used on these plant growth facilities, no matter when the growth facilities they are, whether it's for agriculture or for recreational marijuana use. But growth facilities in itself use quite a bit of mechanical heating, cooling, dehumidification, things like that. So Denver has said, let's put some requirements on that. For dehumidification, you need to meet one of the following. I put or more. You know, you can always meet more. Denver's not going to yell at you for meeting more than one of these things, but you need to meet at least one for dehumidification. You need to have freestanding units for dehumidification, chill water system with heat recovery, or an integrated HVAC system with heat recovery. And then dehumidification backup. You know, if for some reason your main dehumidification is not working, then you want to have some type of backup, electric or fossil fuel may be used as a backup, but only when, as a backup, only when the primary system can't meet that need during the peak period. So that design need is 60% is the threshold Denver came up with. So the other thing with these indoor agricultural operations, you basically also need to make sure your cooling equipment still meets the efficiencies. So your EER or your SEER, just because it's a grow facility doesn't mean it's exempt from meeting efficiencies. And those efficiencies are in table or C403.3.2, which you can look up. Again, I didn't put those in the presentation because there's pages and pages. And based on what equipment is being used, you're going to have different efficiencies that need to be met. But they do still need to be meeting those efficiencies just as normal. All right, that's it for mechanical. Let's. I think there's only 2 or 3 slides for plumbing, and then we'll wrap up with commission and call it a day and open it up for questions. So for plumbing, we're talking about domestic water heating. You can see nothing crazy has changed. That's why there aren't too many slides on that. But big change, I would say, from 2015 to 2018 is the instantaneous gas water heater. So you can see this gas water heater, or that's electric setup, sorry. Gas water heater from 2015 efficiency was only 62. Now in 2018, it's required to be 82. So that's the big change here for instantaneous gas water heaters. In my opinion, I see mostly in Denver electric instantaneous water heaters. So it's a little bit different on that. But Denver didn't have any changes from 2018 to 2015. They didn't modify that. The thing that has changed a little bit, we'll see from Denver here in red. So high input water heater, so anything over 1 million BTUs input, if you're looking at the code is 90% AFUE. But Denver said, look, we're going to bump that up to 92%. So again, something our modeling and ComCheck won't catch. So this is something that you might want to look at to make sure that if it's over 1 million BTU, your surface water heating, it's actually 92% AFUE and not 90% AFUE. Just a heads up on that. And the last thing in plumbing here, heat traps are now required on all types of tank type systems. So if there's a tank, they need to have a heat trap. And it needs to be on both sides, both the hot and the cold. The code used to say only non-circulating systems heat traps were needed, but now the new code says all tank type style systems need to have heat traps, and they need to be on the vertical lines. Pretty easy to check on the plans, pretty easy to check in the field. Just make sure the heat trap is installed for any tank style or type system. All right, so we're done with mechanical somewhat. We're done with plumbing somewhat. We got some loose ends to catch up on in sections 406 and 408 that relate back to mechanical and plumbing. So that's why we're going to go over these. So section 406 says you have to pick one of these options. The red, in this case, are added options from the last code to the new code cycle. The asterisk under reduced lighting power density, I know that doesn't relate to mechanical or plumbing, but just so you know, a Denver amendment occurred for that option. We won't go into that, but that's why it has a red asterisk next to it. So the reason why Denver made it an amendment to pick 2 of these is that a lot of people were picking this reduced lighting power density. And that was a freebie if you're doing LED lighting pretty much. And so Denver wasn't seeing the energy savings as much as they were because people were already doing LED lighting, and so they were basically getting credit for something they were already doing and just picking that as their option. So Denver said, fine, go ahead and pick your reduced lighting power density, but we're going to make you pick 2 of these. So if you want to get the freebie, go ahead and take the freebie, but pick another one to help reduce how much energy consumption we're doing or how much energy consumption we're having in the buildings. So if you want to pick 2 that aren't free, or maybe there are 2 that are free, but really you just have to pick 2. It doesn't matter which 2, but you have to pick 2. So because the 2 new ones don't have to do with mechanical, it affects the mechanical. I won't go into those in much detail, but enhanced envelope performance. Your mechanical system is only as good as your envelope. If you have a leaky envelope, then your mechanical system is going to have to work harder. It's going to have to work more often, things like that. Your energy consumption is going to go up. So you can pick this enhanced envelope performance, which basically is saying it's going to be 15% better than what is required in the booklet on the code. That's one of your options. Maybe you're already there. And then the other one is reduced air infiltration. Again, you're looking at thermal envelopes, so maybe R values for your enhanced envelope performance, insulation values. And then reduced air infiltration, that's your leakage. And so that's just saying you have to pass an air leakage test, which is required actually by the City and County of Denver anyway, but we're not going into that in detail because this is a mechanical section. That will be on our architectural section on Thursday if you want to hear more about that testing that's required by City and County of Denver. So as you can see, we've gone through the slides here. We've gone through the mandatory sections that you have to go through. We got one more thing to cover here, which is the last blue thing on the bottom, which is mandatory as well, commissioning. And commissioning isn't necessarily mechanically focused, but commissioning does focus heavily on the mechanical, electrical, and plumbing systems. So how do we know if a building needs to be commissioned? Well, remember we had that slide at the beginning that showed all the different pathways, and Denver has, Energize Denver. They have the Green Building Ordinance. They have the Green Building Code. They have the IECC. Well, just like that, there are thresholds for commissioning. So LEED has its own requirements. IECC has its own requirements. ASHRAE has its own requirements. So how do you know when a building needs to be commissioned? Well, if you're following IECC, it's based on equipment capacity. That capacity is 480,000 BTUs of cooling or 600,000 BTUs of heating and domestic combined. If your building or equipment hits that threshold of energy use, then commissioning is required for those mechanical systems per IECC. And, I got to do a rule of thumb, if you're looking at, tonnage, for, how many tons per square foot, this and that. Rule of thumb that you can use, but, probably shouldn't use is roughly 10,000 square feet. If you got small, like Kentucky Fried Chicken that's, got these deep fryers and has a lot of BTUs being used for heating and cooling, that building might only be 5,000 square feet, but it's, HVAC capacity is probably going to hit the threshold for IECC commissioning. So it's a rule of thumb that's not really a rule of thumb, but if you want something to start with about 10,000 square feet, but it's really based on equipment capacity for the IECC. And then from an electrical standpoint, commissioning is required if the lighting load is over 20 kW or greater. Again, not really mechanical plumbing, but just so you know. So then ASHRAE has its own thresholds. ASHRAE says that's just based on square footage. If the building's 50,000 square feet or bigger, then you're going to need to commission the equipment. Okay, easy enough. So remember, if you're following the IECC pathway, you have one threshold. If you're following ASHRAE pathway, you have another threshold. Well, what about Denver? Denver didn't change those thresholds for IECC or ASHRAE. They just added to it. What they added is building envelope commissioning is required, which is more for air leakage and insulation values and things like that. So not something from an MEP standpoint that you have to worry about from Denver's. That amendment they changed is more from, I would say maybe more on the architectural side of things. And then LEED, well, LEED has its own requirements. And LEED says, well, no matter what size your building is, no matter what capacity your equipment is, no matter what, you have to commission. So if the building's going after a LEED certification, well, commissioning is being done. And commissioning is one of those things that is a requirement for City and County of Denver. So that might be a cool little trigger point. You see, oh yeah, it's going after LEED. I know it's going to hit the commissioning requirements. I don't need to check as closely what's being done on commissioning in my plans review and things like that, because I know that it's following LEED's requirement. Now, what LEED says is if the building is under 20,000 square feet, it allows for the installing contractor or somebody else, a non-third party, to commission the building. So that's a little bit different there. The building's still being commissioned. It's just not being commissioned by a third party per se. It doesn't need to be commissioned by a third party. So just know those commissioning thresholds. Keep those in your back pocket, because that's something that needs to be checked on the plans that commissioning is being done. And then also, before you can issue a final CO, commissioning report has to be provided to you. So something you want to check. So what are the required systems? Well, mechanical systems have to be commissioned. Domestic water has to be commissioned, and lighting systems have to be commissioned per the code. The two asterisks there are building controls. Well, that's kind of inherently commissioned based on your mechanical. So if you're doing mechanical commissioning, you're looking at those controls anyway. So it doesn't specifically call out building controls, but inherently the building controls are being commissioned as well. That's why there's an asterisk there. And then the asterisk on the envelope is for the City and County of Denver's amendment that require the building envelope to be commissioned. So last slide here before we'll open it up for questions. So the code official needs this commissioning compliance checklist before you can go out and, well, actually before someone can even call for a final inspection. And this compliance checklist is in the code book, but this version right here on the screen is actually Denver's amendment to the code book. It's pretty darn close to being the exact same thing, but know that there are two different checklists out there. One that Denver has amended and one that's in the code book. So make sure you have the right one. They're pretty darn close. And this has to be filled out before they can ask for a final inspection CO. So the other thing that needs to be that is new in 2018 that you all need is this commissioning report actually needs to go to the code official before a final inspection. That's new in 2018. Denver amended that to have that in 2015, but actually in 2018, that's a requirement, even if you're outside of Denver. So not only do you need this compliance checklist, but you actually need the preliminary commissioning report before you can be considered for final inspection. And, you know, to be honest, that benefits everybody. It really benefits you all because some of the things that that Section 403 that had to deal with controls that, you know, field inspectors aren't looking at, the commission agent is looking at. And so you can, you know, dig through that report if you want, or, you know, just peruse it and spot check it and look to see if some of those things have been done. And now you can feel better about doing your job completely because you have the commission agent's report that shows that it's been verified that it's been done. So those are the two things that the code official needs before calling for a final inspection, which are two pretty big things. And the reason for that is we want to make sure that the building is operating as efficiently as possible before the owner gets that building. You know, once tenants get in there and occupants, things tend to slip. You know, oh, well, yeah, we forgot to do commissioning, you know. It's been, you know, it's been 12 months, but, you know, we'll get it done. Well, that's 12 months of energy use that's, you know, hurting the city and county of Denver's goals. It's actually hurting the pocketbook of, you know, whoever's paying the bills too. So it's really beneficial for everybody that commissioning's done and verified before you can get a final certificate of occupancy. So with that, I'll open it up for questions. I haven't been sharing that, but Erica, if you have any questions that have come through, or if anybody wants to unmute their line, we got about 20, 25 minutes to answer any questions. Hopefully I didn't bore you all too much.
Thank you, Kevin. It's a great presentation, and we do have a couple questions. First, to start, was one comment that we received in the beginning was about the 15% reduction in energy cost when compared to the standard reference design building. And one of the attendees commented in the Denver amendment, it was actually changed to 24%. So I just wanted to confirm that with Christy or Keith, feel free to speak up here too, or Kevin, if you knew of that. Feel free to comment.
Sure. So I thought it was 15, but I could be wrong on there. So if Christy or Keith wants to have a correction, or if nobody knows for sure off the top of their head, we can send the response in our email follow-up with that clarification.
I'm opening up the amendments now, taking a look at it.
Okay, great. All right, well,
I believe that is correct because we did raise the bar on the performance approximately 10% beyond base code. I'll let Keith provide the final confirmation, but I believe that is correct.
I believe it is too. I just was trying to verify that.
Okay, great. We do have another questions while we verify. Is there anything that we should be specifically focused on from the commissioning report?
Yeah, good question. So I would say, the commissioning report can be very long. It can, I've seen, I've even done some commissioning reports where, they're maybe as short as 10 pages all the way up to several thousands of pages. But I would focus on probably the functional, they have to provide you with the functional test procedures and the deficiency list or issues log that they found during their tests. And I would focus probably just on those two items. If you just look through even the issues log to make sure items have been closed out, I think that's one of the big things that I'm seeing that people want to get their CO, and so they're like, just issue a preliminary commission report, and I can do that, but the preliminary commission report still has, several open items that have not been addressed, which, the whole intent is to make sure we're closing these items out so efficiency of the building is operating at its peak area before the owner gets it. And if items are open and they get a final CO, then that doesn't do, that's basically finding a workaround in the code. So I'd say look at your issues log and look at the functional test results.
Great. Thank you, Kevin. And then we do have one other question. What is the difference between economizer and energy recovery?
Sure. So both are to utilize less mechanical cooling, and economizer is basically saying that is free. The outside air is at the best operating conditions, and you can use it to help cool the building without using mechanical cooling. That's the same thing as an ERV system, except for the range of outside air temperature or humidity can be expanded. So, for instance, you don't want to be bringing, so if you have, if it's 55 degrees outside, and you need cooling in your space, well, why don't you just bring in that outside air from an economizer and turn off your mechanical cooling, and you have free cooling for the space. And ERV says, well, maybe we can get up to like 75 or 80 degrees outside air because we're using heat transfer with exhaust air to get that free cooling. So that's the difference between the two. Both are using outside air to reduce mechanical cooling, but the ERV actually allows for a larger range of outside air temperature.
Perfect. Thank you. Keith, were you able to confirm that number of 24%?
That's for the Appendix G, is that correct?
The comment
yeah, I think that's what they were talking about.
The comment says Denver amendments, sections, and a list of bunch of sections that I believe are in the IECC. So
the copy that I have shows on the Appendix G still at 85% for both the energy cost approach and the energy source approach.
Okay.
Yeah, that's what I got, which is 15%.
Right.
Yeah, and then that's new to Appendix G, but then for IECC, it looks like there's also a percentage to beat.
So let us get back in a response on this, because I think what might be showing up there is what we put into the Denver Green Code. So let us just straighten that out and be super clear in our response. I'd rather just have a chance for us to be thorough in our digging and make sure that we're giving the full information.
And actually, I do see in his comment there, he does reference C407, which C407, the IECC performance path, does have 76%.
Okay.
I did find
Thank
that,
you.
and I do see in his comment there.
Perfect. Okay, well, if there are any other questions in addition to those, feel free to unmute yourself or write in the chat. Kevin and I will stay on the line for another couple of minutes if any other questions do come in.